10. A firework rocket is fired vertically upwards. The fuel burns and produces a constant upward force on the rocket. So the fuel burns and produces a constant upward force F on the rocket. After 5 seconds, there is no fuel left and air resistance is negligible. What is the acceleration before and after 5 seconds? So here it is mentioned that air resistance is negligible, and what is the acceleration of the fuel before and after 5 seconds? So if let's suppose this is our rocket, then as the fuel is burned, the rocket is moving upwards. So the weight of the rocket is acting downwards and a constant upward force is acting upwards. So force is acting upward and weight is acting downwards. And as we know that resultant force is equal to mass into acceleration, that means the resultant force here is forward force minus backward force is equal to mass into acceleration. That is forward force minus mg is equal to mass into acceleration. So this is our original equation to find the values. Now from this equation, as we know that the fuel is burnt, so as fuel burns, so normally it has some mass, but as fuel burns, the fuel is being used and so the mass decreases. Since the mass of fuel is lost, so the mass decreases. So mass decreases. Now if we rearrange this equation, then force is equal to ma plus mg, and here mass is decreasing as the fuel is burned. That means before 5 seconds, as the fuel is burned, mass is decreasing, and here it is mentioned that the force is constant. So this force is constant, that is this is constant. Now this force is constant and mass is decreasing, and so what is the acceleration? This force is constant, and so left hand side is constant, and to make the right hand side constant, J is obviously constant since J is the gravitational field strength, that is 9.81. so J is constant, mass is decreasing. That means to make the right hand side equals to the left hand side, as force is constant, so acceleration must increase. Since mass is decreasing, so acceleration must increase in order to balance the left hand side is equal to right hand side. Therefore acceleration is increasing. That is, as the force is constant, J is constant and mass is decreasing, so to make the left hand side is equal to right hand side, acceleration must increase. Therefore acceleration is increasing. And after the 5 seconds, that is all the fuel is being used up, forward force is equal to mass into acceleration plus mg. That is, I write this equation. So for this equation, the fuel is being used up, so now the mass is the mass of the rocket, and the mass of the rocket is constant. So mass of the rocket is constant, then g is also constant, and as the fuel is being used up, there is no forces acting, so the force is 0. As the force is 0, so if we rearrange this equation, then mass into acceleration is equal to negative mg, and since force is 0, so mass into acceleration is equal to negative mg, and gravitational field strength is constant, mass is constant. As the mass is constant on both the sides, so we can cancel each other out, and acceleration is equal to negative g, that is negative gravitational field strength, and gravitational field strength is 9.81, that is negative 9.81. so as we can see that acceleration is also constant, that is the negative gravitational field strength. Therefore acceleration is constant. So the answer is C.